In this stunning image taken by NASA's Juno spacecraft, Jupiter's southern hemisphere is seen in great detail. The view also captures one of the white ovals in the string of pearls, one of 8 massive rotating storms at 40 degrees south latitude on the gas giant planet. At the time the image was taken, the spacecraft was 20,577 miles from the tops of the clouds of the planet at a latitude of minus 52.96 degrees. This view captured by Juno spacecraft shows a close-up view of numerous storms in the northern hemisphere of Jupiter. The luminous beauty of Jupiter's clouds can be seen in this view. The bright colors give a vertical dimension to the clouds, and the tiny bright white clouds are the highest, casting shadows on the next layer of clouds. Splashes of orange may be the color of the deepest clouds viewed through the openings in the pastel layer. At the time this image was taken, Juno was over 53 degrees south latitude at an altitude of about 29,800 miles above the cloud tops. Intricate cloud patterns in the northern hemisphere of Jupiter is seen in this view taken by Juno spacecraft. At the time the image was taken, the spacecraft was about 7,659 miles from the tops of the clouds of the planet at a northern latitude of 50.2 degrees. This view of Jupiter gives the impression of a painting that's ready to be framed. The view was taken by Juno spacecraft from an altitude of about 7,900 miles above Jupiter's cloud tops. Jupiter's northernmost cyclone, perched near the gas giant's north pole, is visible to the right along the bottom edge of this image. Jupiter has 8 circumpolar cyclones and 4 are visible in this image, framing the northernmost cyclone. A small anticyclone, which spins counterclockwise, has wedged its way in just above the northernmost cyclone. The image was acquired from an altitude of 17,248 miles and shows features as small as 11.6 miles across. Images from Juno spacecraft's camera show different cloud and storm systems and provide a great view of the evolution of Jupiter's atmosphere. Juno has many instruments that allow us to look inside the cloud layers to examine Jupiter's winds and make other measurements that help us learn more about the planet's interior. Here, a dolphin-like cloud appears to be splashing through cloud bands in Jupiter's southern hemisphere. Layers of clouds swirling in Jupiter's atmosphere can be seen in this view. Sharp boundaries of storms cast thin shadows on the clouds beneath the storms at about 50 degrees north. The smallest, brightest clouds, dubbed pop-up storms, are likely composed of bright crystals of ammonia. Juno spacecraft was just 4,900 miles above Jupiter's cloud tops when this image was captured, and details as small as 3 miles across can be resolved in the image. This view shows high-altitude electrical storms on Jupiter. Juno spacecraft's sensitive stellar reference unit camera detected unusual lightning flashes on Jupiter's dark side during the spacecraft's close flybys of the planet. Jupiter inspires both artists and scientists with its amazing beauty. This stunning image of Jupiter was captured by Juno Cam, the camera on NASA's Juno spacecraft in orbit around Jupiter. This image, derived from data collected by the Jovian Infrared Auroral Mapper instrument aboard Juno spacecraft, shows the central cyclone at the planet's north pole and the 8 cyclones that encircle it. The colors in this image represent radiant heat. The yellow, thinner clouds are about 9 degrees Fahrenheit in brightness temperature, and the dark red, thickest are around negative 181 degrees Fahrenheit. Swirling clouds on Jupiter can be seen in this image, which shows new detail in the clouds and storms. Juno's orbit around Jupiter changes every time the spacecraft passes the giant planet, with the point of closest approach perizove moving steadily northward. As the perizove changes, the resolution of images taken in the northern hemisphere steadily increases. Taken at an altitude of 4,133 miles, this image reveals features as small as 2.8 miles across. As Juno spacecraft was racing away from Jupiter, it snapped this view of the south polar region from about 29,100 miles above the cloud tops, while the spacecraft was over 65.9 degrees south latitude. The image shows the amazing variety in Jupiter's stormy atmosphere, with a surreal world of vibrant color, clarity, and contrast. 4 of the white oval storms, known as the String of Pearls, are visible near the top of the image. Interestingly, one orange-colored storm can be seen at the belt zone boundary, while other storms are more of a cream color. Dramatic atmospheric features in Jupiter's northern hemisphere are captured in this view from NASA's Juno spacecraft. The new perspective shows swirling clouds that surround a circular feature within a jet stream region called Jet N6. At the time, Juno was about 8,000 miles from the planet's cloud tops, above a latitude of approximately 55 degrees north. Jupiter's zonal winds going in opposite directions generate eddies of all sizes that manifest in storms swirling in the atmosphere. At the highest level, pop-up clouds, the small bright clouds that amass at the edge of one of these fronts, are thought to be parcels of air pushed up to the altitude at which ammonia ice condenses. Although they appear to be small, these bright storms may be 16 to 31 miles across. This image captures Jupiter's north temperate belt, which was taken as Juno spacecraft performed its close flyby of Jupiter. While performing a close pass of Jupiter, Juno spacecraft took this stunning image of Jupiter's stormy northern hemisphere. Some bright white clouds can be seen popping up to high altitudes on the right side of Jupiter's disk. At the time the image was taken, the spacecraft was between 11,600 miles and 5,400 miles above Jupiter's cloud tops, above a northern latitude spanning from about 59 to 34 degrees. This view shows an area within a Jovian jet stream which shows a vortex that has an intensely dark center. Nearby, other features display bright, high-altitude clouds that have puffed up into the sunlight. At the time this image was taken, Juno spacecraft was about 9,200 miles from the planet's cloud tops, above approximately 52 degrees north latitude. Swirling in Jupiter's atmosphere for hundreds of years, the Great Red Spot is captured in this close-up image. The giant storm churns through Jupiter's atmosphere, creating the turbulent flows to its west. On the west side of Great Red Spot itself, a silver of red material is being pulled off the periphery. This is a recent, frequent phenomenon first observed in ground-based data in 2017. When this image was taken, Juno was about 43,500 miles above Jupiter's cloud tops. Features as small as 31 miles can be resolved in the image, allowing us to see structure in the interior of the Great Red Spot, as well as the fine texture of the white clouds in the south tropical zone below. The Juno spacecraft is constantly beaming back spectacular images like this here that are impressive on their own, with only select ones being processed by scientists. NASA has said that the images not only provide a spectacular look at Jupiter's swirling, turbulent atmosphere, but also countless revelations about the inner workings of the massive and mysterious planet. These complex colors and structure of Jupiter's clouds were taken when Juno spacecraft was about 3,300 miles above Jupiter's cloud tops at a latitude of about 50 degrees. The image reveals some of the most intriguing aspects of Jupiter's atmosphere, including color variation that results from differing chemical composition, the three-dimensional nature of Jupiter's swirling vortices, and the small, bright pop-up clouds that form in the higher parts of the atmosphere. A multitude of magnificent swirling clouds in Jupiter's dynamic north-north temperate belt is captured in this image. Appearing in the scene are several bright white pop-up clouds as well as anticyclonic storm known as a white oval. At the time this image was taken, Juno spacecraft was about 4,400 miles from the planet's cloud tops at a latitude of approximately 40 degrees north. Jupiter's turbulent southern hemisphere is seen here, which also shows the notable Great Red Spot as well as a massive storm called Oval BA. The storm reached its current size when three smaller spots collided and merged in the year 2000. The Great Red Spot, which is about twice as wide as Oval BA, may have formed from the same process centuries ago. The turbulent regions around and even the shape of the Oval BA storm have significantly changed since its discovery. The storm has further transformed in recent times, changing color from reddish to a more uniform white. Intricate swirls in Jupiter's volatile northern hemisphere are captured in this image. Bursts of bright white pop-up clouds appear scattered throughout the scene, with some visibly casting shadows on the neighboring cloud layers beneath them. Scientists often use shadows to determine the distances between cloud layers in Jupiter's atmosphere, which provide clues to their composition and origin. The intensity of the jets and vortices in Jupiter's north-north temperate belt is captured in this amazing view. The view is oriented with south on Jupiter toward upper left and north toward lower right. The north-north temperate belt is the prominent reddish-orange band left of center. It rotates in the same direction as the planet and is predominantly cyclonic, which in the northern hemisphere means its features spin in a counterclockwise direction. Within the belt are two gray-colored anticyclones. To the left of the belt is a brighter band, the north-north temperate zone, with high clouds whose vertical relief is accentuated by the low angle of sunlight near the terminator. These clouds are likely made of ammonia ice crystals or possibly a combination of ammonia ice and water. Although the region as a whole appears chaotic, there is an alternating pattern of rotating, lighter colored features on the zone's north and south sides. Scientists think the large-scale dark regions are places where the clouds are deeper based on infrared observations made at the same time by Juno and Earth-based supporting observations. Those observations show warmer and thus deeper thermal emission from these regions. To the right of the bright zone and farther north on the planet, Jupiter's striking banded structure becomes less evident and a region of individual cyclones can be seen interspersed with smaller, darker anticyclones. A multitude of bright white pop-up storms appear in this Jupiter cloudscape image. A dynamic storm at the southern edge of Jupiter's northern polar region dominates this Jovian cloudscape. This storm is a long-lived anticyclonic oval named North-North Temperate Little Red Spot 1. It has been tracked at least since 1993 and may be older still. An anticyclone is a weather phenomenon where winds around the storm flow in the direction opposite to that of the flow around a region of low pressure. It is the third largest anticyclonic oval on the planet, typically around 3,700 miles long. The color varies between red and off-white as it is now, but this image shows that it still has a pale reddish core within the radius of maximum wind speeds.